Use the method of differences to find an expression for the sum of all the cubes of natural numbers. Now, in the previous video, we just used the result, but now we're going to do a direct proof of it. Okay, so the sum from r to 1 of r cubed is going to be 1 cubed plus 2 cubed plus 3 cubed plus some general term cubed, and then the last but 1 will be n minus 1 cubed, and the last term will be n cubed. Now, the method of differences I actually did in my previous video, so the link to the actual method itself, the sort of theory behind it, is in the previous video, and the link will be, you can find at the bottom of this video. So what you need to do is choose a function, and I'm going to choose this one, r brackets r plus 1, and that's all squared. And then if I do, you have to then work out f of r minus 1, and then r minus 1, so because r will become r minus 1, r plus 1 minus 1 will become r, so it becomes r minus 1 r all squared. We just need to choose a function here that when we work out the difference of these two, that we get some multiple of r cubed. So now f of r minus f of r minus 1 is equal to, so that will be r plus 1 all squared minus r minus 1 times r all squared. Now there's a common factor here of r squared, so we'll take that out. Expanding r plus 1, we get r squared plus 2r plus 1, and then subtraction of r minus 1 all squared, which is r squared minus 2r plus 1. Put in the extra brackets there, and get r squared plus 2r plus 1. Taking the minus sign in, we get minus r squared plus 2r minus 1. And then we can do a little bit of cancelling. So the r squared cancel out and the 1s cancel out. We've got 2r plus 2r, which makes 4r. So we've got r squared times 4r, and we've ended up with a multiple of r cubed. Right, so the method of differences says this, and again I'll repeat, the actual method itself, the theory behind it, is in the previous video, so please look for that in the link below. So the sum from r to 1 of n of a particular term is going to be f of n minus f of 0. So in our case, we're going to do the sum of r to 1 of 4r cubed. I know we want r cubed, but at the moment it's 4r cubed. Will be f to n minus f of 0, where f of r in this case is r plus 1 all squared. Just writing that out again. So we'll take the 4 out of the sigma sign because it's a constant, which you can do. And then we will just put in n into our function, so that will be n times n plus 1, all of that squared. And obviously, because we just want, and we also should put 0 in. Okay, if we do put 0 in, we just do actually get 0. Okay, if we then divide by 4, that will give me the sum of all the cubed numbers of natural numbers, being n times n plus 1, all squared, all divided by 4. And again, this result should be memorized because it can be quoted. Okay, so it's been a video to show you the proof, direct proof of finding the sum of all the cube of natural numbers using the method of differences. I hope you've understood, and I thank you very much. And I'll just repeat, if you want to know about the theory behind the method of differences, please look at my previous video. Thank you very much.